Hello and welcome to Supplier Soundbytes, S&P Global Mobility's concise Autology podcast series, where we sit down with supplier experts to explore what's changing in automotive and why it matters. One topic, one clear takeaway in around 10 minutes. In today's episode, we look at how automotive engineering is evolving in response to new technologies and shifting market demands. Joining us from MAHLE Powertrain is John Hollingworth, Sales and Marketing Director. Hi, John. Great to have you with us.
Hi, Matthew. Nice to meet you.
We'll discuss everything from battery electric vehicles and range extenders to hydrogen combustion, renewable fuels and thermal management. We'll also explore how engineering, testing and validation are changing as vehicles become increasingly software defined, connected and continuously updated throughout their life cycle. So to start this one off, John, MAHLE often talks about technological diversity. With regulations and infrastructure and customer demands varying so much around the world, how do you decide where to focus your biggest investments and engineering efforts?
Oh, thanks, Matthew. That's an interesting question. I mean, it was a decision that we made probably about 10 years ago. Historically, we've always been a combustion engine business, and we had to look at where the market direction was going and to see if that was where we were going to reshape our business for the future. But we made a very conscious decision 8 to 10 years ago, looking at sort of battery electric vehicles and would that be a future and should we change our business direction, and decided that actually that probably wouldn't be the right way to go forward because we still weren't convinced that actually that was going to be the full picture. And if we'd have diversified away from combustion engines and into battery electrification, it would have pegged us into a corner. So we looked at it, and rather than actually go out and find people that could design batteries, we decided to retrain our people that were used to looking at combustion engines to be able to design and develop batteries. And you mentioned in your introduction, it's about mentioning thermal management. And if you look at a battery, it's a thermal management problem, really, stringing a lot of cells together, but actually managing the thermal properties of the battery is just as important to make sure that you optimize the full performance of the battery. But then you also look at a cylinder head, and actually a cylinder head and a cylinder block is also a thermal management problem. So you've got again flow of coolant and fluid through a block and a head, and actually managing the coolant to be managing the temperatures to be in that optimum range. So actually, our best cylinder head designer that's been designing cylinder heads for over 30 years became our best battery design lead. And so he's now delivered several battery projects, and it was only recently that we picked up a new hypercar engine project that he pleaded with the business, can I have another go at a cylinder head again? So actually our staff have now sort of been cross-trained across both of them. And it's been quite lucky because you can see in the industry at the moment as well that the industry had all set to go full electrification because that's where the politicians were dictating through legislation. That's the only way we could go forward. And now you've seen a reversal of the EU Commission of where their ban on tailpipe emissions has been softened. So the industry is now turning back and sort of looking at combustion engines and can we make them more efficient and can we use combustion engines in different ways like range extenders and things like that. So actually it's positioned as well to make sure that we're a technology agnostic company and what we're here to solve technical engineering problems, and that's what we do.
That's great. Very interesting evolutionary story, that. Thank you. I'll come back to thermal management in a minute. So that's an interesting focus too. Just staying with that theme, where do you see range extended EVs fitting into the market? Are they mainly a transition technology, or could they become a longer term solution for certain vehicle segments and regions where charging infrastructure is still developing, would you say?
I do think there's got a long-term position for it, and the range extender technology is another strange position for us because back in 2010 we looked at the electric vehicle market or what the future of the electric vehicle market would look like, and as predominantly a combustion engine company, we decided that actually the solution for electric vehicles was a combustion engine or a range extender engine. Because we looked at people's journeys, and the majority of people's journeys was around 70 kilometers per day. So they didn't need the huge ranges that the OEMs were searching for, because you could have a small, very efficient two-cylinder, well, as we've decided, two-cylinder engine to fit alongside the battery. So like our sort of solution for battery electric vehicles was actually designing an engine. We actually installed that into a demonstration vehicle again back in 2012 and showcased this to the whole of the OEMs and the automotive industry. And no one was interested. They all felt that battery electric vehicles were a long way away yet. And by the time they came, the range would be good enough and the charging speed would be good enough that it would be competitive to a standard gasoline engine. Well, we're here now. We're in the future. And we've got battery electric vehicles on the marketplace, and they're quite expensive because the batteries are expensive and they are not delivering the sort of charge speeds that everybody expected. And sort of the infrastructure is still not there as well across the whole of the network. But if you go back to our original history of looking at people's journeys, and if people only need to do about a 70-kilometer journey, it does mean you can have a smaller battery. So less cost and a very low technology sort of development engine alongside of it. So the majority of the time you can run on electric 100% of the time. But those odd occasions where you go a bit further, then range extenders can sort of come into it, or they can help you get home to always charge from home. So it sort of relieves a bit of the infrastructure around public charging and things like that. So I think there's, well, what we've certainly seen at MAHLE Powertrain is a U-turn recently in the industry of looking at range extenders again. And it's only over the last 2 years we've actually done 2 range extender engine projects for different customers. One was the European OEM and the other one was a Chinese OEM. So you can certainly see that the market is changing, and conversations I'm having with OEMs, I would say they're all looking at sort of what their options are, range extender vehicles. So I think there is definitely a place for hybrid electric vehicles, and sort of more so the range extender type vehicles, because that's the legislation is still very tight on emissions. So you want to predominantly run majority of the time an electric where possible.
That's great. It's interesting to see how the tide is changing in some respects. Going back to that thermal management, I mean, one area that perhaps gets less attention is thermal management, even though it has a major impact on EV range, charging performance, cabin comfort, and battery life. As automakers search for more efficiency, how important will integrated thermal systems become compared with simply increasing battery size?
I think it's critical. The main thing is the batteries within a battery electric vehicle has got a very small optimum operating window. We all know that those that drive electric vehicles, days like today when it's 23 degrees, which is supposedly ambient temperature for the world, the battery, you get a decent battery range out of a vehicle, exactly what the manufacturers say that you can do. But as soon as you get into the colder climates, or even hotter days when it's really hot like it is today, you sort of see the range dropping off a little bit. But actually, if you can manage the actual temperature to keep the battery in that tight operating window, you've got a lot of opportunity to maximize the actual range and sort of the efficiency of the battery. And then as we load the vehicle up with more internal systems as well, like your aircon and passenger entertainment and things like that, that's in the vehicle, obviously you'll put no more load on the battery. So actually you've got to sort of manage the whole vehicle efficiency through the whole vehicle. Certainly cabin comfort comes into that as well, because again, depending on what the temperature, you've got to put a load onto your powertrain, really.
Yeah, thank you very much indeed, John. Just wondering, just beyond electrification, hydrogen combustion and renewable fuels are often seen as more specialized solutions. From MAHLE Powertrain's perspective, where do you see the strongest opportunities for hydrogen combustion, whether in heavy-duty transport, off-highway applications, motorsport, fleet vehicles, or regions where EV infrastructure may take a little longer to mature?
Yeah, I think you've hit the nail on the head, really. I think it's very much dependent on sort of the vehicle type and sort of the duty cycle of that vehicle. If
Yeah.
you look at sort of the heavy duty vehicles, sort of off highway vehicles where they're running constantly all day, battery electric vehicles are still not as energy dense or efficient as what a diesel engine would be. But obviously, you've got to still clean up the roads and clean up the air quality. So We're doing a lot of work at the moment around hydrogen combustion for sort of heavy duty static generators. We're also looking at marine as well at the moment, doing a lot of work using ammonia combustion, sort of using the hydrogen contained within ammonia. And that so those kind of markets we can see that moving into. I think we see in cyclic terms the fuel cell come and go in passenger car vehicles. I think it becomes a fashion thing, but we don't think they're quite robust enough at the moment for full production road car vehicles. And that's where I think the battery electric vehicle will probably sustain its probably biggest area. So I can see that the future is going to be very eclectic. The renewable fuels and synthetic fuels also have a place to play, but then I think that becomes a geographic thing more than a technology thing. So we've tested a lot of sort of the biofuels and renewable fuels, and they work just as well as sort of normal traditional fuels. But actually, certain other countries around the world are more suited to be able to produce those sort of fuels. And then there's still work to go on synthetic fuels to get the price comparative to where the usual petrol is as well. So I think we're going to see an eclectic future. But again, I think to reiterate the point, I think it's very much going to be around sort of the duty cycle that the vehicle runs in and sort of what's the optimum solution for a fuel type for that.
That's great. Thank you very much. Just one final question, if I may. If listeners could take away one key message from this conversation, what would you want it to be? And is the future of mobility about one dominant technology or about finding the most efficient and lowest carbon solutions for each type of vehicle type, market, and use case, would you say?
I think certainly for me, the duty cycle and the use case is the key, really. I think the future is going to be very eclectic. I think there's a job for the OEMs to educate the people who buy cars to look at their own duty cycle and understand what powertrain requirements that are suited to their particular type of mobility. And I think there's going to be all sorts of different options out there for people to choose from. But I think there's that education piece to understand how to choose the right way forward. From an engineering company, as MAHLE Powertrain is, we're saying technology agnostic. So we've developed our skills and capabilities to support an ever-changing automotive industry. So whatever direction we go in, MAHLE Powertrain wants to be in a position to be able to engineer the right solutions for the OEMs.
That's great. Thank you very much indeed, John. And that's all for this episode of Supplier Soundbytes from Mobility Global. Thank you very much for spending time with us. If you found this useful, please do follow us on LinkedIn for more insights from across the supplier ecosystem and keep an eye out for new episodes coming soon. Bye for now.